In the previous video, we looked at how to create a composite rule for a difference between two population means. In this video, we're going to look at how to do a significance test to compare two population means. So our example is, does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is the decrease in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Here are the data. So we've got the groups, the calcium and the placebo. And remember, it was double-blind, which means the people that receive the placebo didn't know if they were getting calcium or not calcium. And the people giving the pill didn't know if they were giving the placebo or the calcium. But that's what the double-blind aspect means. So do the data provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo? Carry out an appropriate test to support your answer. So we are going to use that distribution, the sampling distribution of the difference between two means, which if you haven't seen the first video, then you need to jump back and watch that video to understand that distribution. And we're going to state our hypotheses, which in this case is that there is no difference between the groups, but we are trying to build evidence showing that there is a difference and that the calcium has more of an increase than the placebo does. So our null hypothesis is the mean of C, and you can see the mu of C is the true mean decrease in blood pressure for healthy men like the ones in this study who take the calcium supplement, and mu of P is the same thing, but for those who take the placebo. So our null is that there is no difference. So the subtraction equals 0. We want to prove that this first value is larger. So we want it to be greater than 0. We want the difference to be greater than 0, meaning that the blood pressure is higher. The increase is higher for those who took the calcium pill. And remember that an increase appears as a negative number because if their blood pressure gets higher, like for this person here, their blood pressure actually increased by 4, which is going against what the experiment is trying to determine if there is a relationship. So the state, your hypotheses, they didn't give us an alpha level, so we just picked one of 0.05. And then we will plan where we'll check the conditions to make sure the distribution of each is approximately normal. This would be a 2-sample t-test for a difference between these two means. So we need to make sure we state this in our plan section, and we'll check the random condition. The random condition is a little bit different this time because we didn't take random samples. We had volunteers who were assigned to certain treatments. So this is a completely randomized design. So the random condition in this case is we have to make sure they were randomly assigned to the treatments. And they told us that they were. There were 21 subjects were randomly assigned to either the placebo or the calcium, which means the random condition is met. And so we're not making inference about a larger population here. We're making inference about a cause and effect from this experiment. Next, we'll check the large normal condition, because if we're not sampling without replacement, we don't have to check the 10% condition. Looking at our sample sizes, or the two groups that we're comparing, they're not greater than 30, which is a problem. So we have to look at a box plot or a dot plot or something to see if there's any large skewness or strong skewness or any outliers. So we'll put these in the calculator and see what the box plots look like. Go to our lists of stat, edit, and I'll enter the calcium group here and the placebo group in here. Now I've got the two groups in list 1 and list 2. Let's take a look at our box plot and see their shapes. Second y equals, turn this plot on, make sure it's showing a box plot, outliers, and I'm using list 1 for this stat plot. Let's go up here and I'll turn my second stat plot on. So over here and hit enter. I'll turn this one on and I'll put list 2. Select the box plot and show list 2 here so I can see them both on the same screen. And then I'll hit zoom 9. And there are my 2 box plots. And so if you hit trace, you can see what the values are for each of these. Hit down and look at the next ones. So I'm going to have to copy these over to my notes because on the AP exam, you'll have to do the same thing. But let's take a look. If we see this looks to be roughly symmetric, no outliers. And the second box plot here, which is let's see, this top one is list 1, which is the calcium. So list 2 would be the placebo. And this one appears to be, the median is a little bit closer to Q1 than Q3, but these whiskers are the same length. So there's definitely not strong skewness in either of these, and there's no outliers. So we're good to move on with T procedures. So you can see I've copied the box plots from the calculator. Now, I'll admit I didn't do a great job copying these. I should have just put it on a scale, but I was kind of rushed on time. So I copied them down and you can see there's no strong skewness or outliers. So even though the sample sizes are small, we are good to proceed with T procedures. It may be even easier to do a dot plot for these ones here if you want. So after I've checked my conditions, I can move on to the do section where I find my test statistic and my p-value. In order to do that, I need the information from my sample. So I'm going to copy down the information from my calculator that I have about the samples on my paper first. I've written down and made sure I labeled each sample or statistic according. So the mean of the calcium sample, standard deviation of the calcium sample size, and then of course the placebo listed below. So next I need to find the test statistic, and I'm going to use some space down here just to teach what the test statistic is very quickly. You should remember that your test statistic is the statistic minus the parameter divided by the standard error of the statistic. So since we're conducting a test about means, it's going to be a t-test statistic. And our statistics is really comparing the difference between two means. Our statistic is going to be the difference between the two sample means. The parameter is going to be our null hypothesis. And the standard error is going to be the standard deviation of the difference between the two means. And this is what our formula will look like. We have the difference between our two sample means minus the null divided by the standard error of the statistic, where we have the standard deviation of the calcium group squared over its sample size plus the standard deviation of the placebo group squared over its sample size. And so we'll plug these values from our samples in to get our test statistic in the do section above. So after plugging in and subtracting the difference between the two means, even though remember this one was negative from the placebo group, we calculated the test statistic of 1.604, and now we'll use this to find our p-value, and then we can find our conclusion for our test. I guess we need our degrees of freedom before we can calculate our p-value. So our degrees of freedom is the smaller sample, -1, so our degrees of freedom will be 9. And we'll have to use TCDF with 9 degrees of freedom to calculate the p-value here. And it is a one-sided test because the alternative is greater than, it's not two-sided because it's not a not equals to. Before I open up the calculator, I'll show you a quick picture of what we're going to do to find the p-value using the t distribution with 9 degrees of freedom. So for our p-value, we're just going to use this distribution. We know it's approximately normal from our conditions, and we're going to find the area above a test statistic or a t-value of 1.604. So let's go ahead and open up the calculator, and I'll give you a refresher of how to find these in the calculator if you need that as well. You should still have our lists entered. So our calcium group in list 1 and our placebo group in list 2. So to find the statistics from each sample. We'll just hit stat, calculate one variable statistics, and then we pick which list we want to use. So list one was calcium, so that's where we got the values for our calcium statistics. And we'll do the same thing for the placebo group. That's where I copied those down onto the notes. To find the p-value, we're gonna have to go to distributions, TCDF. Our lower was 1.604. Upper was infinity. Degrees of freedom was 9. So our p-value would be 0.0716. So I'm going to write that down on my notes, 0.0716. Now I've copied this p-value over onto the notes, but I want to show you how to solve this problem on a calculator very quickly and honestly in a more efficient, better way, because the calculator is more accurate than we are using this method with our 9 degrees of freedom. Let me show you why. If we go to stat tests, and this was a 2-sample t-test, because it's about a difference between means, and we entered the data into the list this time. So if I hit over here, this is going to ask me for sample means and standard deviations, but we entered the data into the list. So I'm going to make sure I use data. List 1 is the calcium group, 2 is the placebo. The frequency of each list is 1 because it's not a random variable that has different probabilities of outcomes. My null hypothesis, we said that the calcium group is greater than the placebo group, so that's why I've selected this one. And then for pooled, the only time I do a pooled test is when I'm doing a difference between proportions. This is a difference between means. So then I can calculate, and this is going to give me all the info that I need. There's my null, my test statistic, 1.604 essentially, and it gave me a p-value of 0.0644. So you notice this p-value is a little bit smaller, and a smaller p-value means stronger evidence against the null. And the reason there's a difference is because my degrees of freedom is different. We used the conservative method of just picking the smaller sample size, but there's actually a long formula that you don't need to know about how to calculate degrees of freedom, and your calculator does that. So this is actually more accurate a result for your 2-sample t-test, and this is what I'd like you to use for my tests. You just have to make sure you write down the name of the test, put your t-value, your p-value, and your degrees of freedom in the do section on your test if you want to get full credit from me and from the AP test. So I'm going to take this and copy it down onto the notes as well. Since this is the information I used without the calculator or using 9 degrees of freedom, I'm actually going to erase all this and change this to what I had on my calculator. So I've copied down the info from my calculator, my test statistic, p-value, degrees of freedom. All of these need to make sure they're listed in this do section. And don't forget to list what test you use on your calculator, and you should have it listed up here in the plan section. So as long as you have it here, you should be good. And you need to list these 3 things down here. So now we can finally make our conclusion. We'll measure our p-value against our alpha level. Our alpha level was 0.05. So this is greater than alpha, which means we do not have convincing evidence and we fail to reject the null hypothesis. Since our p-value is greater than alpha, we fail to reject. Our experiment does not provide convincing evidence that the true mean decrease in blood pressure is higher for men like these who take calcium than those who take a placebo. And it is important that you say for men like these, because since we didn't randomly select from a population, we can't say this is true for all types of people. It's just for men like this in our study. That's as far as our scope of inference can be.